Questions on anything we've done so far? Good time to get those ready. I won't ask what they are until we do start recording. And there's Sierra. Good morning. And help me with your name. Jayla. There you are. And, oh yeah, you were here already. Okay, got it. 2 papers in today. Way to go, folks. All right, keep them coming. I need more things to grade. No, I didn't say that, did I? Okay. All right. So, let's set up from the current slide. And before we start recording, big news before we start recording, if I can find it, here it is, okay? I finally did get the class code from Cengage, and here it is. Lawson, wait, let me get my pen set up. Okay. Lawson, Lawson.al space 2874 space 8031. Okay. That is the Cengage code that you need to be able to access your ebook, and there's some WebAssign problems on there. They picked them out. I don't know how many, what they look like, but WebAssign does have good tutorial help. I told them I wanted all the tutorial help they could get, so knock yourself out. There, that should be everything that you need to access everything about the course. Okay? Now, I meant to say this earlier, and it just sort of dawned on me. I mean, we talked about it back when we went through the syllabus, but that was a long time ago. But now that we're actually doing the math, now, I don't know, I sort of was afraid. I was getting a few sort of deer-in-the-headlights looks from a few people in the class. I couldn't tell if that's just how you normally look or if you really were a little bit lost. But if you are, there are tutorial sessions that are going on. Some of you probably already enrolled in them, but even if you're not, if you were not told that you had to be in it, but you are finding this to be a little too abstract, a little coming at you a little too fast, then I think that you can go to those tutorial sessions anyway. Okay, Gary's here. Okay, and especially maybe for those who weren't here at the very beginning and just added the course and you feel like you're a little bit behind, go to those tutorial sessions. Now let me show you where they meet. And if they don't want you in there, they should be able to tell you where you can get some tutoring. But here we are, here in this quarter room. You go out in the hall, go down this long hallway here, take a left at the end, and that very first classroom past the stairwell, it says it's a classroom. It's not really set up for a classroom, but it's really great as a tutoring room. And it's A209A. The English is in 209B. So you're in the math is 209A. You got great people there, good tutors, and if they can't help you, if they can only handle the students that are in the class, in their classes, the tutorial sessions, they should be able to tell you. Let me point out a couple of other places you can go. Since you're down there, anyway, if you go all the way to the end, just before you get to the restroom, the last office on the left, it says it's a classroom, it's really an office now, that is Student Support Services. They provide free tutoring, generally peer tutoring, but sometimes they have professional tutors as well. So that's available too. The actual tutoring lab is up here, right across from this second stairwell. Okay, that tutoring lab there, I think it's 202, I believe it is. And the person who used to be there moved to a different job. I don't think they've replaced her yet. So that place is sometimes locked. That's why I say go down here to the office, which is 212, I believe it is. But if that doesn't work, go down that flight of stairs right there across the hall from 202. And when you get to the bottom of the stairs on the first floor, take an immediate right and go into the Space Center. No, that's not that kind of Space Center. But you'll see the sign right over the door, Space Center. Go in there, and they provide free tutoring as well. So, lots of opportunities. If this is going too fast and furious, or you don't feel like your background is quite there, the WebAssign has good tutorial help. And then we have at least 3 different possibilities here on this campus. Now, if you go to the Birmingham campus most of the time, there's great things there. SSS has tutoring. And I can tell you how to get to those places there. The Space Center has tutoring at the Leon Kennedy Center on 2nd floor. And also the STEM Lab has tutoring. I don't know what their hours are, but I can tell you how to get to all of those places as well. And then you can come see me during office hours as well. All right, any questions? All right, where we left off last time, okay, any math questions from what we did before? Hope everybody was able to do your homework exercises. Now that you'll either have your books or ebooks or whatever, you can do even more. But we're on 10.3, multiplication of polynomials. Okay? Everybody got the code, right? All right, that's the access code for Cengage Unlimited. So you can get to this book, this course in that book. All right, here's objective 10.3a. We're going to multiply a polynomial by a monomial. Now, this is so bizarre to me. They have so few slides, and 3 of them are taken up telling you what we're going to do without telling you how to do it. It's just what we're going to do. Multiply a polynomial by a monomial. And that's a pretty simple thing. Okay? And this is Rebecca, right? Okay. All right. Good deal. Now, I think we kind of know how to do this, don't we? Okay? Multiplying a polynomial by a monomial. This is a lot like multiplying. Give me a fairly large number. 3 or 4 digits. Second? A little louder. 657. And if you're going to multiply that by, give me a single digit number. 8. Okay? We would multiply each of those digits by 8. Carry anything if you wanted to, add it together. That's how we do it. Okay? Well, multiplying a polynomial by a monomial, we usually don't do it vertically. We usually do it horizontally. Here's how we do it. The rule is to multiply a polynomial by a monomial, use the good old distributive property and the rule for multiplying exponential expressions, things that we've already been doing. Now, do you remember what distributive property is? Like this, they just jump right into it. They don't give you any examples. They just say, here, do it. All right, so what would you do first? Distribute the negative 2x in and multiply, just like we did with numbers, each term by that multiple. So negative 2x times x squared would be negative 2x cubed. Excellent. And then the negative 2 times the negative 4x would be plus 8x squared. Excellent. Next. A little louder. Plus 6x. Got it. Success. 6x. Okay, never mind. Okay. So there's your A1. Pretty straightforward. Distribute what's outside by inside. The things to watch, the things that trip up more people than anything else, are the signs. Watch those signs. They like to stick their foot out there and trip you, okay? So don't let them do it. Minus times positive is minus. Minus times minus is plus. Minus times minus is plus. Okay? What if they put the monomial on the other side? Who cares? It's the same thing. We just do it this way. What would that be? Negative what? 10x squared. Perfect. And? Minus 8x. Perfect, perfect, perfect. And what if they have a big old power on the monomial on the outside? Who cares? We can do it. What does that give us? 2x to the 5th. Excellent. Minus 3x 4th. Perfect. Plus 2x cubed. Excellent. Okay. Let's see if when I advance this, it's going to muddle it. Ha! No, it doesn't. Here's the A1. They show in gory detail how you multiply the 2x by each term inside here. Okay? Now, doesn't really matter where they put this minus out front. That's perfectly fine. That's the trouble with doing it this way. You think, oh, you have to do it this way. Just make sure you account for it. Okay? And when you multiply those things together, you get a negative 2x cubed. Yes. A plus 8x squared. Yes. And a plus 6x. Perfect. Everybody see it? See how it works? Why it works? Good. Let's see if we can get the B one to work. There it is. Okay? And it doesn't matter what order you do it. They put the 5x times the minus 2x plus 4 times minus 2x. This will give you what? Minus 10 x squared minus 8x. Let's see if that's what they get. Minus 10x squared minus 8x, just like we did. Good for them. They were copying us, okay? And then the last one we won't be able to compare on. But, hey, look at what they did. They skipped all those intermediate steps and went right for the jugular here, okay? 2x squared times x cubed is 2x to the 5th. They just did it all at once. Minus 3x times x cubed is minus 3x to the 4th. And plus 2 times x cubed is plus 2x cubed. Yes, just what we got, right? Any questions on that? All right. That was on page 7. Your objective 10.3a practice problems are on the bottom of page 7. There's only 4 of them. Please do all 4 just to get the exercise. It won't take you long. Do those 4. If anyone needs to come take a picture, if you haven't got your book activated yet, you can do it. Now you got the code. Now, yeah, Rebecca, you came in. Did you get the code? Okay, let me scroll back for just a moment here. There it is. There is the course code. Lawson.al space 2874 space 8031. Okay. Sorry it's so late getting here, but you have it now. So you should be able to access these and be able to do the, do the exercises from the book. Okay? Now, all right, let's go back where we were. I think it was at the very end of the slide set, but let's just see if they had anything. Oh, that was right. That was the last slide. All right, ready for Objective 10.3b. Okay, let's go for it. This is so much fun to have to change PowerPoint programs. All 5 slides, or 6, sorry about that. I was making fun of them. Okay, 10.3b. Or not 3b, okay. All right, we're still doing polynomials. Module 10, polynomials. 10.3 is multiplication of polynomials. And now, objective 10.3b, multiply two polynomials. Not a monomial and a polynomial, but polynomial and polynomial. Before we do that, give me a 2 or 3 digit number. Whoops, let me get my pen set up. 2 or 3 digit number. Help me. 354? Yeah. Okay, 354. And maybe a 2 digit number.
16.
Second? 16. All right. Sweet. Okay, never mind. Okay. How do we multiply these together? A digit at a time. 6 times 4, 24. You carry the 2. 6 times 30. You carry, okay. 6 times 3, you then you do 1 times 4, you do 1 times 5, 1 times 3. You multiply every term by every digit by every digit. You do it in a very organized fashion, but that's what you do. And you carry numbers if you need to. Guess what? Multiplying two polynomials, not much different. Not much different at all. Multiply two polynomials requires repeated application of the distributive property. And if you want to do it this way, you certainly can. Perfectly fine. They take this one and multiply it by this and multiply it by that, this and multiply it by that, and then this and multiply by this, this, and this by this, and this by this. If you want to string it out that way and do it, you certainly can. Perfectly legal, absolutely correct. Okay? I kind of favor just doing a digit at a time. Now, it might get a little messy, and if you don't like messy, and that's neater for you, go with neat, okay? But you see, we have a golden retriever, so we like messy, okay? Golden retrievers are sweet dogs, but boy, do they shed. Okay, here's how I do it. I do this one times this one times that, this one times that, this one times this one times that, and this times that. I don't draw the lines in there every time, but that's how I do it. And that way, you get all of them accounted for. Just like we did with numbers. You multiply each digit by each digit. Multiply each term by each term. Okay? It works either way you do it. Okay? You could have even done this. Y times this thing minus 2 times that thing. Rather than picking this one to do by each one, pick each term here to do by that one. That actually saves you a little bit of writing. There's tons of ways to do it. Any way that's right works. Okay? As long as it works, you can go for it. Now, a convenient way of multiplying two polynomials is to use the vertical format similar to that used for multiplication of whole numbers. Okay? And I guess they're going to show that on the next slide. Okay? But this is horizontally. That works really well. I like it. Okay? So here we do. You want to do it vertically or horizontally? Or both? Name something. Horizontally. Let's do it horizontally. You want to do it their way or my way? I like it. You get extra points. No, you don't. Okay. Let's do 2b cubed times 2b. What does that give you? Say again? I can't hear your coefficient. 4b to the 4th. I'm hard of hearing. Okay, next. Plus 6b cubed. Okay, you've got this one times both of those. Let's do this one times both of those. And what do you have there?
2b to the 6th.
Minus 2b squared, or not to be squared, okay? And then minus 3b, okay? You got now the first one times both of those, the second one times both of those. Now let's do the third one times both of those. plus 2b. Oops, I'm going vertical, am I not? Okay, and plus 3. Okay? In this case, I went vertical because we had like terms. I like to do that. Okay? What does this give you? Pretty easy. 4b to the 4th. A little louder. Plus 6b cubed. Help me. Minus 2b squared. That was the easy part. Now this one. Minus b plus 3. There we have it. Now that's one way to do it. You can distribute another way. There's two different ways you can distribute. You can string them out long ways horizontally and combine like terms that way. I just like combining like terms this way because it helps me get them all together and make sure I don't miss it. Okay? Now, my loops and dupes at the top get a little confusing, so if you don't like that, do it a different way. Okay? Does that make sense, sir? Okay. Now, here's something, maybe a little check for you. Okay? You have 3 terms here, 2 terms there. You ought to have a total of 6 terms. 1, 2, 3, 4, 5, 6. Yeah. You combine those together, however. If you wind up with fewer terms than that, you miss one somewhere, go back and find it. Okay? So that may be a little bit of a help, especially since it gets a little confusing. Let's see how they did. Y'all got the answers. I'm going to have to erase this one, I'm pretty sure, because it'll right on top of it. So let's see how they did it. Okay, they did it. If you find this helpful, do it. It's fine. If I were going to write this vertically like they did, I would skip and bring this 2b cubed over here because what are we missing here? A b squared term. They did it down here. Why didn't they do it up there? That would have made it make a lot more sense. Okay? But you don't have to. We didn't do it before. You don't have to now. But since they did it here, why didn't they do it up there? I don't know. So, here's what they're doing. They start with the 3, just like you did. Remember when you did numbers? You started here, did 3 times 1 is 3. 3 times minus b is minus 3b. And then 3 times 2b cubed is 6b cubed. So you see if they brought this over there and left a space, or even write in 0b squared. That would have been legal in most states, okay? It would have been perfectly fine, okay? Then you would have had a 0 here, okay? You don't need it, but you could have done that, okay? Now, guess what we're going to do next? You tell me. Yes, we're going to do this one, and that would be, say again? 2b or not, okay? And then this would be 4b, sorry about that, to the 4th, okay? And this is a plus here. No, I skipped a term. Oops, there it is. Okay, what's that one? Minus 2b squared. And that's why the space is there, okay? I didn't do that very well, did I? Okay, so this gives us, all right, 4b, and you know how I caught that? I looked and said, I only got 5 terms, I need 6, because I had multiplied 2 times 3. Oops, I missed that. Okay, yeah. So anyway, that would be 4b fourth plus 6b cubed minus 2b squared minus b plus 3. I think that's the same thing we got before, right? Okay, let's see if it's what they get. Yep, there they go. They fill it in, almost as neat as mine, sort of. Okay, and then they draw their line and add 4b fourth plus 6b cubed minus 2b squared minus b plus 3. Got it. Many ways to get there. All roads lead to Rome. Take any route as long as you do correct steps to get there. Don't make up new rules for yourself, okay, that don't work, okay? As long as all your steps are right, you should be able to get the right answer, okay? Was it after this class or after one of my, I think it was after this class, a few students were in here talking about, you know, their kids in school, and teachers say, no, you got to do it this way. You know, maybe you experienced that too. And I cringe when I hear people say it, because math is somewhat intuitive, but it's also logical, and as long as you follow the right, any logical path, you should be able to get the answer, and that's perfectly fine to get it, okay? Now, I don't mean to demean teachers, especially at lower levels, but here's why I fear, I may be wrong on this, that happens. And a friend of mine who was in education told me this. She was talking to a group of us, and she said she had been a PE major in college, okay, in education. She wanted to teach PE. She's a good athlete, volleyball, I can't remember why, probably several sports, softball maybe too. But she was a good athlete. She was a PE. She was real good at what she did. She got her certificate, everything, and went to her interview, got her first job, went to her first job, and they said, oh, you're the new teacher? You teach math. Okay? And she said, wait, I'm a PE major. I do math. I like math. I'm fine with math, but I'm a PE. Well, no. You're a teacher. They teach math. Nobody wants to teach math. So they assigned it to her. So here's what you get. And here's what this woman said. This is her words, not mine. She said, when people go to college, no matter what their major is, now this was at an ag school, this University of Georgia. And she said, what's that?
Can we stop today on this?
Second.
I was asking how today was done and moving the days. I couldn't hear you.
Wait until they stop moving that.
She can't hear you.
Okay. There's no who's moving this. There's no one upstairs, because there is no upstairs. Maybe it's down. Okay. All right. Well, this isn't really math. It's just my talking. Okay. So you're not missing a lot. Okay. But here's what the woman said. She said that kids go off to college, and she was talking about University of Georgia, and when they, whatever their majors are, when they find out they hit that first math course, and when they find out they don't like math or they're scared of math or you know they can't handle it, she said the guys go to agriculture and the gals go to elementary education because they think that's going to be the least math. Actually, our elementary education major here has more math than most other majors, except math and engineering. But I really appreciate that they're doing that. But this was years ago now. So what you wind up with sometimes, now this is always the case, what you wind up with is the teacher for math, and especially those lower levels, are the people who are newest on the block, new teacher, you teach math, have the least experience teaching, and sort of scared of math to begin with. Now, not all elementary education majors are like that. Many of them are good, and if you got one of those for your kids and you become one, fantastic. That's just what we need. But many times you'll wind up with the least experienced teacher and the one who is scared or difficult. And guess what? He or she is going to teach the student to be scared of math because they are scared of math. And so you have to do it this way because that's the only way I understand it. You know, basically that's what they're saying. I'm sorry. That maybe ought to be what they're saying. Maybe they're instructed they have to teach it that way. Boy, math should be fun. Okay? It shouldn't be, you got to do it this way. Never mind. I'll get off that horse and let's go to the next problem. What's that? Okay. All right. So, there's how we multiply. And that was the last one. Boy, is this ever an extensive book. Okay. That covered through the bottom of page 8. This is Module 10, page 8. Okay. And at the top of page 9, there are a big 3 problems for you to do. Please do the practice problems. Top of page 9. Okay, all 3 of those. Now, guess what? If you can't get the answer, if you don't know how to do it, flip over to Module 10, Supplementary Section S, page 5. And there they have the worked out ones. They have that at the bottom of every practice product. They tell you where the answers are and how to do it. So do it. Okay. So that finishes that one. All right. And we go through this again. Really big 5 slides there. Okay. I did not want that. I don't know what you're doing. Okay. I don't know why it came up that. Why is it doing this? That's not the thing that you would say. Okay. Let's go to 10.3, C. Okay. That's yes in Spanish. Okay. All right, here we go. Slideshow, current slide. This is so much fun to do every time. We're still in Module 10. We've seen this slide on every one. That's one of the slides in the slideshow. Every time. Polynomials. 10.3, multiplication of polynomials. And our objective for 10.3c is to multiply 2 binomials. My word, we just did multiple ones. This is even easier. Okay? I bet you y'all have done this before and you had a special little technique. Anyone remember what I'm talking about? Yes, curses, foiled again. Okay? Multiplying 2 binomials. It is often necessary to find the product of 2 binomials. Just like the product of binomial from trinomial. It's easy, but that product can be found using the FOIL method, which is based on distributive property. It's just what we were doing before, only this time we have a little acrostic, is that what you call it, to go by. FOIL stands for first, outer, inner, last. Okay? So, here, they really show you how to do these, don't they? So let's multiply these. The first. Whoa, let me get my pen set up. So much fun to do this every time. Okay, let's do the first. What do we have there? Say again? 12x squared, is that what I heard? All right, good. And then we do the outer, and what do we have? Plus 8x. And then we do the innards. Innard. Say again? Minus 9x. Now I'm doing it vertically. You can do it horizontally. It doesn't matter. And finally, do the last. And what do we have there? Plus 6. Excellent. Now, besides having a smiley face, isn't that nice? We can combine like terms. And what do we have? What do we have? 12x squared. Say again? Minus x plus 6. Done. It's the same thing we were doing before, but now we have a little acrostic we can go for it. Now, I've already mentioned the phrase here, and I bet you none of you recognize it. None of you remember the old, you do recognize the old comic strip or comic cartoon thing, Rocky and Bullwinkle. You remember that? Fantastic. That was one of my favorite of all time. Rocky. Huh?
I'm 32 years old.
Oh, yeah, but I'm way more than double that. Okay. All right. But Rocky and Bullwinkle. Rocky was a squirrel. Bullwinkle was a moose, and they were goofy as all get out, especially Bullwinkle. And they were always, this is back in the Cold War era, and they were always battling against Boris and Natasha. Okay? Good Russian names, right? And Boris and Natasha were shrewd and clever and really smart, and these two were just clowns, you know. And yet Rocky and Bullwinkle always managed to disrupt Boris and Natasha's evil plots. And at the end of it, Boris would always say, "Curses foiled again." So that's what I say with foiling method. Curses foiled again. We did it. And we have a smiley face to go with it. We're Rocky and Bullwinkle. Yay. Okay, never mind. All right, you didn't need that, did you? Okay, but you got it anyway. No extra charge. All right, let's see how they did it. Let's erase the ink. And sure enough, they wrote it again. That's good. And then they spelled out FOIL. Good for them. The FOIL, the first is 4x times 3x. And the outwards are 4x times a minus 2. The innards are minus 3 times a 3x. And the last are minus 3 times minus 2. And again, folks, the thing that will trip you up and get you the worst are those signs. So watch the signs. So this will be 12x squared minus 8x. Whoa, I must have missed it, didn't I? I missed it. Oh, my goodness. Fire me. Okay. I did it wrong. Okay. I had one of those as a plus. I messed it up. See, I told you the signs would reach out and trip you, didn't I? I was just illustrating that for you. It was intentional. Right. Okay. Okay. Minus 9x plus 6. Okay? So when you add those two like terms, that gives you minus 17x plus 6. Sorry, I got it wrong. Okay. Y'all are kind. Okay. So, see, I shouldn't have been talking about Rocky and Bullwinkle, should I? Okay. Never mind. Okay. Hey, if you catch me making a mistake, say something. I wish I could say I give you extra points, but I don't have that many points to give, so never mind. Okay, let's go on from there. Oh, man, that's the end? We just were going good. Okay. 3B, 3C. That was on Module 10, page 9. And at the top of Module 10, page 10, you have 5 practice problems. Please do all 5 of those. They're easy, and they snuck a couple things in on you. They actually put 2 variables in one of them. It works the same, nothing different there. Okay? The last 2 have multivariables. All right. Now let's go to 10.3D. Okay? This is so much fun to have to do this every time. All right. All right, here we are, 10.3D. We'll go from current slide and get my pen adjusted. And we're still doing Module 10, polynomials. And 10.3 is multiplication polynomials. And 10.3D, this time we're going to multiply binomials that have some very special products. Okay? Now, these are going to work just like the other multiplication. There's nothing new here, except in the next chapter, what are we going to be? A module, we're going to be factoring polynomials. And guess what factoring polynomials is going to have us do? Undo multiplication of polynomials. It's just like division. So we're going to undo it. So that's why it's really important to pay attention to these. Okay? Some special products. Here's one expression. This expression, a plus b times a minus b, is the product of a sum and a difference of 2 terms. This is the sum of 2 terms, a and b. This is the difference of the 2 terms, a and b. Okay? Now, later in your math life, and hopefully you'll get there, you will call these conjugates of one another. You keep the first one the same, but change the sign of the second. And we will use this when we're doing radical expressions. We'll use it when you're doing complex numbers. We'll use it lots of places. You'll use it in trigonometry. We'll multiply by the conjugate, and that will help simplify things. So get used to that. Here they just call it the product of the sum and difference of the same of 2 terms. This is multiplying an expression by its conjugate, a binomial by its conjugate. You don't need to know the term. The first binomial is a sum because it has a plus in it. The second is a difference because it has a... Wow, I'm glad they pointed that out for us. Okay, the 2 terms are a and b. Yes, I think we got it. The first term in each binomial is A, and the second in each binomial is B. Okay, they said it a different way. Got it? Good. Okay. The expression, okay. They jumped another rabbit here. The expression A plus B squared is the square of a binomial. That's something else we're going to do. We're going to do this, and then we're going to do this. Now, why they went to this much length to do this and then threw this in, here the first term is an A and the second term is a B. Wow, they got that down really well. No, don't they? These are two different issues. We're going to do them separately, but they put this one on the same page. I don't know why, but it's fun. Okay, it's really good. Now, let's use the FOIL method, because this is multiplying two binomials together. Well, let's see what happens when we do that. Well, the first, I'm going to write it in here. Okay, FOIL is first. A times A is A squared. There it is. Outer minus AB entered plus AB last minus B squared. There we have it. Now the thing to note here is, look at the cross terms. Minus AB plus AB, what does that add to? Say again? They cancel out. They add to 0 every time. Every time. So when you have the sum times the difference of the same two terms, don't worry about FOILing. Don't go back and reinvent the wheel. Just write down the first one squared minus the second one squared. That's going to be the answer every time you multiply a binomial by its conjugate. Just write down the first one squared minus the second one squared. And you got it not. See, that's being lazy. Did I tell y'all my theory on being good at math? Yeah, I think I did. Be a little lazy. Hey, a great place to be lazy. When you see that, sometimes the difference, same two numbers, difference of their squares. Okay? Now, where is this going to come important later? When you see a difference of two perfect squares, you can factor it just like that without hardly any thought. Okay? But we'll get there later. That's next module. Okay? Any questions on this? Okay? Let's practice on one of these. Okay? You want to FOIL it, or you want to go straight for the answer? I don't care. Tell me. FOIL or answer? FOIL, okay? Oh, did you say answer? Okay, do the answer. What's the answer?
80 squared.
Say again?
80 squared.
Okay, where'd you get an 8? Oh, okay, well, 4x squared. Okay, I got that.
Minus 6.
Yeah, 9. That's it. Okay. Took a while, but he got it. Okay. It's the multiplication that got him. It wasn't the process. Okay. You could have FOILed it. 2x times 2x is 4x squared. 4x squared. Okay. And the outer would have been minus 6x plus 6. That adds a 0 every time. This is multiplying conjugate. And then a minus 9. There it is. Difference of the square. Square this, minus that, square that. Done. Just like that. And you paid money for this? No, I'm sorry. Well, we won't go there. Okay. It's that easy. Okay? Is that making sense? Okay? All right. Let's see how they did it. I'll erase mine. Everybody got it? Okay. And they wrote down the problem again. Then they wrote them down with squares by them, which is perfectly fine to do. If that helps you see it, do it. And then they squared it and you got 4x squared minus 9. Now, writing it this way does introduce another little issue. When you see a minus 3 squared, were any of you tempted to say that was a plus 9? You were. Okay, resist temptation. No, I'm just kidding. Okay, here's the deal. Remember, hopefully you've had this before, your rules for order of operation. Please excuse my dear Aunt Sally. I don't know what she did, but please excuse her, okay? And what does the P stand for? parentheses, okay, and then the E, exponents. You always do exponents before, my dear, multiplication or division. So you do the exponent, and then the last was, Sally is adding and subtracting. This is a subtraction. Do the exponent first, then subtract. Square that, make it 9, then subtract. So the rule of order operation has you do it right. Whereas doing it the other way, we just said the difference of their squares. So that way you eliminated the possible error there, but rule of order operation helps you keep from doing that error. All right, good deal. Make sense? All right, that's the sum and the difference of the same two numbers, multiplying those, or multiplying a binomial by its conjugate. I'm going to keep saying that word because you'll use it later in math, and it's a fun word, okay? Now, what if we're squaring a binomial, okay? What does squaring anything mean? Multiplying it by itself, is that right? Yeah, so if you're squaring a binomial, you multiply that binomial by itself. And then you can FOIL it if you want to. Okay, let's do the FOILing. Okay, I like to do the little loop-de-loops. A times A is A squared. Outer is minus AB. Inner is minus AB, and the last are, this time, plus B squared, right? Minus times minus is plus. Well, here you wind up with two of these. The innards and the outers are the same, okay? So therefore, you add them together, and that gives you minus 2AB, okay? That's doing the FOIL method, and it's not hard. You can do it every time, okay? If you want the little shortcut, here's what it is. Square the first term, twice the product of the two terms, sign included, 2 times AB, minus 2 times AB, and then plus, always plus, the square of the last term. Works every time. And that way you don't have to go through FOILing and get a smiley face and all that kind of stuff. But, you know, you can always FOIL it. So there's more than one way to do it. You don't have to do the little rule. Square the first, twice the product, and then square the last. But you can. It's pretty easy. Make sense? Okay? I think they're going to give us an example, don't you? One and only one, but they'll give, oh, all right, how are we going to do this? Now, you can either write down the answer, or you can spread it out and FOIL it. I don't care which way you want to go. You tell me. Second? FOIL it, okay? How would you write this as a product? 4C plus 5D times 4C plus 5D. That's what it means to square something. Multiply it by itself, okay? Now FOIL it. First is 16 C squared. The outers are, second, plus 20 CD, and the innards are plus 20 CD, always the same when you're squaring, and plus 25 D squared. When you combine like terms, you get 16C squared plus 40CD plus 25D squared. Which, if you had done the rule, square the first, 16C squared, twice the product of the two is 20CD, twice that is 40CD, and then square the last, 25D squared. Remember, no matter if that's a plus or a minus in there, when you square the last term, it's always going to be positive. So like the person's always going to be positive. The middle term here is determined by the sign there. If that's a plus, this is plus. If that's a minus, this is minus. Same rule always works. Okay? You can either FOIL or you can use the rule. They both work. Make sense? You got a choice. You paid your money, take your choice. Okay. Now, let's watch how they did it. I'll erase what I did. Everybody got the answer right. So let's go to this. And they just went straight for the jugular, and they squared the first, though they wrote it down that way. Twice the product of the two, they wrote it down that way, and then squared the last. If they're going to do all that, go and foil it. I mean, that takes just as much writing. Okay? And that gives you 16 c squared plus 40 cd plus 25 d squared. See it? Works every time. Whoa! And that was the last one. Okay? Wow, they sure give a lot of examples, don't they? Okay. At the top of Module 10, page 12, you'll find 5 of these. 2 of them are multiplying conjugates, and 3 of them are squaring binomials. Okay? Now, 10.4, I can't remember if we were supposed to do that or not, but we're making really good time, aren't we? Okay, so let's go on and do 10.4. It's good, buddy. Okay. Wait, that's not what I wanted. Okay, that's what I wanted. Okay, that's what's supposed to come up. Okay, I guess I know what I'm doing differently. Okay, so let's go get the new one up. This will be, oh no, I guess we weren't supposed, oh yeah, 10.4a, here we go. All right, I'm sorry. Now, we are supposed to do this. But guess what? We are more than halfway through the module. The module has 5 sections, 10.1, 2, 3, 4, and 5. We're through 10.3, so guess what time it is, folks? Quiz time! I knew y'all were excited about it, weren't you? Okay? So here's your first quiz already. Okay? Take home quiz. Each one has a couple. Okay. Each one has a couple. Each one has a couple. Each one has a couple. Each one has one. Each one has one. No, it's over there. You pass that one. Yeah. Got problems here, okay? Each one has a couple. Sideways. Each one has one. One has 2. Okay. I need a read from you guys. Is this going too fast, too slow? Is the pace okay? Is anything going to make it better? Okay. Please do this. What's that? No, only if you're having problems with them. Okay. If you're acing your way through them, that's perfectly fine. If you're having trouble and say, I don't know how they got here, okay, then turn it in to me and I'll help you see what you might be doing wrong. The practice problems are practice, okay? Any of you play football or basketball or tennis or any sport, piano, okay, anything like that? Only way you get good at it? Practice, 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 okay? Now, y'all probably don't remember this guy, but he was one of my heroes, Michael Jordan. Many people still contend one of the greatest basketball players of all time. Okay? He got cut from his junior high team. And he got so mad at the coach. He left after he got cut, and then he spent the next year shooting hoops. Practicing, and came back to the coach. Okay? He became the greatest basketball. Guess what? He had all the tools. I'll never, if I had practiced that much, never become a Michael Jordan. But he had the tools, but they were no good to him until he practiced. And when he did, became one of the greatest athletes, I think, of all time.
Did you use the ball back in the day?
Say again?
Did you use the ball back in the day?
Did I do what with
Ball.
Yeah, did I shoot? Yeah. Okay. I played basketball. Okay? I was never any good at it, but it was one of my favorite sports. Okay, make fun of me. I was pretty good on defense, but boy, I could never shoot with it too, you know. So, but I love the game. Yeah. So played football too, but I was so slow I was not much good at that either. I ran track, but I could do 2 miles, and most people couldn't. So that was my claim to fame there. I even, when I was in intramurals at college, did a little bit of soccer, even though I'd never had a skill in my life, but it was still, I just like to get out and do things. Used to, anyway. Okay, let's move on to module. Have I already brought it up? I think so. Or is this the old one? No, this is the new one. Okay. So let's go to the slideshow. Okay. Oh, and let's say a few things about the quiz. Okay. I tried to do a few problems from each of those 3 sections. The first few, and they may be mixed up a little bit because it's a really awkward test bank they have, but I think I finally figured out how to do it, but I got a few of them out of order, but it doesn't really matter. I always have this question: do I need to show my work? That's up to you. I grade the answers, okay? If you get it right, fantastic. If you get it wrong, then I like to go back and look and see where you made your mistake. If I can see some work and you're heading in the right direction, I can give you partial credit. That's my prerogative. But if I don't see any work and you got it wrong, sorry, okay? I can't give you much partial credit, can I? So I like to see your work, especially if you're going to miss it. So if you're going to miss it, show me your work. Okay, but it's a good idea to show your work. A lot of people absolutely require it. To me, if you get the answer right, I'm all for you. Okay? Now, so Module 10 is still polynomials. 10.4, though, is integer exponents and scientific notation. Okay? Most of the time, we don't do this in Math 100. Okay? I never have before, but it's a nice thing to do. We're going to simplify expressions containing integer exponents. Okay? Whew, okay. What does this mean anyway? The quotient. We haven't done any quotients, have we? The quotient of 2 exponential expressions with the same base can be simplified. I think I told you about it, but we didn't actually do it. By writing each expression in factored form. Now, you'll find this is a long way, but this shows you what's happening. What does it mean to say x to the 5th? That's x is a factor 5 times. That's x times x times x times x times x, 5 times. And divided by x squared, that's x times x. Well, x over x is 1. X over x is 1. You're left with 1 times x cubed, or just x cubed. Okay? So, they can be simplified by doing it that way. Or, remember, mathematicians like to do it the easy way. Come up with a rule so you don't have to write all that down. Let's see. If we keep the base, if you're dividing 2 expressions, same base, different exponents, or even same exponent, keep the base x, subtract the exponent. 5 minus 2 is 3. You got the same answer with a lot less writing. I'm lazy. I like it. Okay? Go for it. You can always do that if you don't like the rule, but the rule makes it a lot simpler. To divide 2 monomials with the same base, subtract the exponents of the like bases. Okay? It just said it again. Okay, good for them. Okay. Now, this works as long as that base was not 0. Okay? Because for any number a, not quite any number, as long as a is not 0, a divided by a is 1. 7,484,816 divided by 7,484,016, or whatever I said, is 1. Anytime you divide a number by the same number, a variable by the same variable, anything by the same, as long as that's not 0, because you can never divide by 0, then you're going to get 1. That property is true for exponential expressions as well. As long as x isn't 0, x to the 4th divided by x to the 4th is 1. X to the 483rd divided by x to the 483rd power is 1. Okay? So, no matter what the exponent is, as long as the base is not 0, as long as it's the same exponent. And guess what? This leads to something else. If you go back to the rule we did, you do x to the 4 minus 4. What's 4 minus 4? 0. And what's x to the 0? 1. Anything to the 0th power, except 0. You can't do 0 to the 0th power. Anything. Pi to the 0th power is 1. 15 to the 0th power is 1. Negative 3 to the 0th power is 1. Okay? Anything to the 0th power except 0 is 1. So sure enough, the same rule work that we did before works here. But x to the 0 is always 1. As long as x isn't 0. Then it's fine. Okay. So here's a definition of 0 as an exponent. If x is not equal to 0, you have to say that, then x to the 0th power, no matter what x is, no matter what it is, as long as it's not 0, is 1. Okay? The expression 0 to the 0th is not defined. You can't do it ever, so don't even try. All right. So, what would that be? As long as a is not 0? That would be 1, yeah. 12 to the 0th 1. 3 times a to the 3 times 0 is a to the 0. That's 1. Anything to the 0th power is 1. How about this one? Okay. Remember our rule for order of operations? Okay. The minus is out here. That right there is 1. And then the minus makes it minus 1. Do the subtraction last. The sign change last. Now, if that was in parentheses, minus y to the 4th in parentheses to the 0th power, that's 1. Because it's something to the 0th power. But this, you do the 0th power first, that's 1, then negate it. So always wait and do that last. So that is actually a minus 1. Because it's minus the thing to the 0th power. The thing to the 0th power is 1. Okay, does that make sense? All right. So, okay. Now we're going to get to a place where we have, if n is a positive integer and x is not equal to 0 again, then x to the minus n, here's the rule. If you have a negative exponent, no matter where your expression is, send your expression on the other side of the dividing line and make that exponent positive. So x to the minus n is the same as 1 over x to the n. If the minus n was already in the denominator, send it upstairs and lose the sign. The sign of the exponent, not the sign of the number, not the sign of the expression, the sign of the exponent. So if you have a negative exponent, if it's in the numerator, send it downstairs, lose the exponent, and lose the minus sign. Okay? If the minus exponent was in the denominator, send it upstairs and lose the sign of the exponent. Okay? Make sense? So each example below, simplify. Okay. What's x to the minus 10th? Write it with positive exponents. What would that be? 1 over x to the 10th. Perfect. Okay. What's 1 over a to the minus 5? A to the 5th. Perfect. What is 2 to the minus 3? 1 over 2 cubed. And what's 2 cubed? 8. So it's 1/8. Good for you. Does that make sense? Any questions on it? I know it's going sort of fast and furious, but is that making sense? All right. Okay. So, the rules for dividing exponential expressions. If m and n are integers, don't you just love it when they start talking in terms of letters rather than numbers? Or m and n are integers. Now remember, integers can be either positive or negative or 0. Okay? All those are integers. They can't be fractions, decimals, and things like that. They're integers. Whole numbers with positive or negative or 0. But now the x can't be 0. Okay? So how in the world are we going to do x to the m divided by x to the n? What was the rule? Same base, different exponents, dividing. Keep the base and subtract the exponent, m minus n. We've done this a few slides ago. Nothing new here. Okay? Except now, m could be positive, negative, n could be positive or negative. One could be bigger or smaller. It doesn't matter. It works every time. So what would that be? X cubed divided by x to the 5th. There's a couple ways you can do this, folks. So that would be what? X to the 3 minus 5, which is x to the minus 2, which is, if you don't like writing negative exponents, 1 over x squared. Perfect. Or you could say, this is x times x times x times x times x times x. You get 5 of those, 3 of them cancel out, it'll leave you 2 in the bottom. You could get there directly that way. Yes?
Will you take x to the negative 2 or do you want it in the bracket?
What's that?
Would you take x to the negative 2 or did you want it in the bracket?
X to the negative 2 of what?
Yeah, if we put in x to the negative 2 on the test,
Okay.
take that.
Okay. It depends on what they say. If they just say simplify the expressions, okay. I don't like the rule for dividing exponential expressions. If they say using only positive exponents, then do what they say. If they don't say that, you can leave it x to the minus 2. I don't care. Okay? But if they do say, if the instruction says using only positive exponents, then do what the instructions say. You'll lose a point for not doing what the instructions say. What would that one be, by the way? Y to the what? 8, exactly, because it's 6 minus a minus 2, and minus a minus is plus, so 6 plus 2 is 8. Excellent. What does this one do? Woo. Say again? Okay. B to the negative 4th, which is 1 over b to the 4th. Perfect. Way to go. How about this one? Everybody? Did you see it? B or a to the 3rd. You're right, because minus 4 minus a minus 7 is minus 4 plus 7 is a cube. Perfect. 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 Does that make sense? All right. Now. So. Okay, we got a couple more minutes, don't we? Right? Okay. The rules for simplifying exponential expressions and powers of exponential expressions are true for all integers. Okay? Guess what? They're also going to be true for real numbers as well. We won't go there yet. These rules are restated here, so here's a summary of what we've been doing. M and N and P are all integers, positive or negative. Then x to the m times x to the n is what? M plus n, you're right. Okay? This one, x to the m raised to the nth is m times n. Remember, when you're multiplying here, your bases here, your exponents get added. One lower effect. When you're raising a power to a power, it's multiplying. Okay, how about this one? Whoops. X to the m divided by x to the n. Say again? No, well, they're not the same. M and n. M minus n. Okay, subtract. Okay? As long as x is not 0, of course, it can't be 0. Okay? How about what is x to the minus n? 1 over x to the n. Okay? That's it, as long as x is not 0. Oh, I missed this one. What's this one? X to the m, y to the n, raised to the p, x to the mp, y to the np. Perfect. Just multiplying them all out. What's x to the 0? 1, always, as long as x is not 0. Okay? Perfect. All right. Now, here's the deal, folks. You've got the quiz. And I always in the past have liked to say you have a week to turn in the quiz. I can still do that, especially if y'all are, want to have that. Okay? And I told you that early on. The problem is we're probably going to finish the chapter pretty soon. Okay? So we will be working on it next time. So the quiz is due in, let's see, today's Wednesday. So next Wednesday. Okay? I am guessing right now we may be through with the chapter at the end of Monday's class. That may be we're ready for the test on Wednesday. Okay. What's that? Oh, that is the good news, bad news situation, isn't it?
Yeah. No school Monday.
Yeah, that's the bad news. The good news is no school Monday, but the bad news that means we won't be meeting Monday. Okay. That's really bad. So you have a week to next Wednesday, so this works out in your favor. But actually, I like to give you 1 day to ask questions. So actually, your quiz isn't due until the following Monday. Okay, but if you don't have any problem with it and can turn it in Wednesday, fantastic. But if you have questions and problems, then bring them to class on Wednesday, and we will. I'll try to address those. So. But you'll need to have it in by Monday because I think we'll be ready for the test on Monday. Now, if you don't feel ready and you need another day or so to study, we can go and start the chapter or module 11 and then come back and do it. So we can be flexible with it, and it's our schedule. We can do what we want. Okay? Good deal, folks. If anyone's not here, excellent. Way to go. Way to go. Yes. What's that? All right. Good. Thank you. Secret.
Okay. Can you show me how to do that? I always had issues with fractions.
Okay. All right. You want to show it on this or on the board or how? On paper. You don't want it on this? Okay. Okay. That's right there. That will be fine. Okay. You want me to go and shut down the thing? Anyone need anything from that you want recorded? Okay, let me go and shut this down.